to do the problem. All right. Number 15, anybody? 9 2/3. 7 2/3. Negative 9 2/3. Negative 3 2/3. 25 over 3. Wow. Uh-oh, we got somebody who agrees. 17 1/12. We're not going to do that anymore. 8 1/3. Ooh, 2 8 1/3. Negative 2/3. Ooh, we got 3 8 1. Looks like that's the answer.
7 2/3.
Ooh. Oh, we got 4. Ooh. Was that 2 or 3 then?
3.
Okay, so again, I feel like we should just go ahead and knock this out. Practice our fractions, especially with the cubes and the positives and negatives. All right, so let me go ahead and move this out of the way, and we'll see who's the winner. All right, now eyes up, please. Because order of operation, as long as we do the parentheses first, it really doesn't matter what order we do the parentheses in. So I look to the easy one. So this over here, what's 1 minus 2? And then negative 1 to the 4th power.
4. Negative 4. 1.
Negative 1 times negative 1 times negative 1 times negative 1 is 1. So this would be a plus 1 here. Is everybody happy with that explanation?
Yeah.
Now I'm looking at negative 2 cubed. What's negative 2 cubed? Well, it's going to be negative 8, but now listen. There's also another negative here, right? So it does cancel out, so it will be a what? Positive 8. Is everybody okay with that so far?
Yes.
Now look, that's what I think you should be able to do. Now I also think you should be able to do pretty good on the mental math as far as the fractions go. So if you're not good at mental math with fractions, please listen. What's the common denominator here? Could be 24, but better to be. If you said it was 24, you're just going to reduce. You get the same answer. So it's not a big deal. So it is 12. Now notice I didn't write 12 twice. It's not necessary. Let me explain why. Because this would be what? 9/12 minus 10/12. Is everybody happy with that? And then I'm going to multiply that answer by what? 8. So what's 9 minus 10?
Negative 1.
So I have negative 1/12 times 8. So I can reduce, right? So I can reduce by 4. That would be a 2. And that would be a what? 3. So that would be a negative what? That would be a negative 2/3 plus 9. Is everybody with me on that? Now if you have 9 pizzas and you're going to cut them into thirds, how many slices will you have? 20 what? I don't think so. You mean that's the final answer? Yes. There's 27, right? So I would want you to think of this as 27 thirds minus 2/3. Everybody happy with that explanation? And so your final answer is actually what? Who said 25 thirds? Or 8 1/3. But I prefer what?
25.
I prefer 25 thirds. Yes, I like your happy dance. All right? I like the happy dance. All right? So again, please now raise your hand if you're going, man, I'm not sure how you got a certain part of that. Anybody have any doubts or concerns or questions? Everybody happy? Good for you. Improper. When you get to advanced math, we don't use mixed. We only use improper. Okay? All right, so here we go. Now we're going to talk about the properties. Did I do 17 and 18 with you, I think, right? I think.
We did almost all of them till like 31.
Did we?
Yes.
All right.
Yeah, we were at 31.
No, 27 was the last one.
Yeah, 27. Okay. So
All right, so 28 then. Now, is the order the same?
No.
No, no, it's not, because it's 4, 7, 6. That's not the same. So what property is it automatically? It's the commutative property of multiplication. 29 is the what? Zero property. Good. Oh, 30. Not many people knew that. Yes, sir. Additive inverse. Because inverse is when you cancel things out. You hear me? Additive inverse. So you may not know what I mean on that. The additive inverse. All right, what about 31, guys? Commutative of the commutative property of multiplication. Correct. What about 32 and 33? Yes, distributive property. Everybody happy with that? Distributive property. 32 and 33 are both the same, the distributive property. All right, what about 34? Commutative property of? Very good. Even though there's some addition held in there. Very good. 35, obviously. And 36? Multiplicative identity. Multiplicative identity. Very good.
Except for 35.
All right. And again, remember, if I were you, I'd be making notes on the ones you made a careless mistake on. All right. Now let's scroll forward. I don't really think this is necessary. I'm gonna give you like 5 minutes to do all these.
Got it.
All right. Now, does anybody need me to review the distributive property? Now let me go through one though. Let's look at 43.
Okay.
Everybody look at 43, and then someone tell me the answer to 43. Go. Is everybody okay with that?
Yep.
Everybody's happy?
Yep.
All right, so you have to be careful when you distribute a negative, you change the signs. All right, so let me give you 5 minutes on, not 5 minutes, about 3 minutes on 37 through 46. Everybody try 37 through 46, please. All right. Caden, I want you to tell me the answer to 37. Now, okay. Now what I want you to do is think on here, though. You can't combine terms, though. Okay, so just do the distributive property first. Tell me what you got.
6x minus 15.
Perfect. Now you stop there. The reason why, because you can't put x's with numbers, okay? That's the final answer. All right. Casey, read me 38. And everybody listen up to 38, please. Just give me the answer.
12x plus 8y minus 3.
Exactly. Minus what? Yes. All right, next. You're going to tell me your first name again. I'm so sorry. Kate, I knew that. Kate. Go, Kate, number 39. Now listen, you made the most common mistake. All right, it should be plus 3y. Can you tell me why it should be plus 3y? That's exactly right. Negative times a negative. All right, thank you, Kate. Tell me your name. Both of you are Tylers? Oh, man, that's why I'm so confused. Oh, my gosh. All right, Tyler, go. You're reading 40. Yes.
Negative 8x plus 12y plus 40.
All right. Next, Tyler.
14a minus 21b plus 28c.
Perfect. All right. Now, Alessandra, you're reading me 42. Yeah, now you're not saying anything wrong. But minus and negative are totally interchangeable, right? Okay, perfect. All right. 54, right? Yes, we did. All right, 44. Maya.
3i negative 18j plus 3.
Perfect. Dang, I was going to say that too. Emails. I got to remember Little House on the Prairie. Did you ever see that?
Yes, sir. Actually,
No kidding. Wow.
everyone's like, "Oh, your parents must be really big fans of Lori Hills Wilder." Well, I'm related to it.
That's
It'd just
really
be weird.
wow, you have to tell me later. That's the only reason I. All right, very good.
I remember some.
That's right. I have my little things.
Oh, you went.
Tell me the answer.
Negative 1a.
Shh, quiet, please. Here, we gotta hear it.
Negative 1a plus negative 1b plus 1c plus negative 1d plus 1e.
Yes. Now we don't have to say the ones though.
All right. Wait.
All right.
I just wanted to make
So
sure.
hold on. So let me say it one more time. The ones are totally fine, but in math we always write as briefly and as quickly as we possibly can. All right. So we would say negative a minus b plus c minus d plus e. All right, that's all you have to do. Plus e. Perfect. All right. 46. Yes, we're going right down the middle.
Oh, me, darn it.
Who's me?
Naomi.
Naomi. I do.
Oh.
Naomi, go.
Negative 6f plus 15g minus 3h plus 18i minus 12g.
You're awesome. Perfect.
It took
All
me
right.
so
Yes,
long
what?
to finish. There's negative 12g and positive 15. Couldn't you combine those to make just 3g?
Oh, yeah. I didn't even pay attention on that. Yeah, very good. So this right here, yes. That should have been.
Yeah.
Yeah, didn't even mean to do that. So you're 100% right. So that's simplified to just what? 3g. Very good. All right, very good for those of you guys who did that. All right. Now, right now, we're just going to get back to defining numbers because I'm occasionally going to talk to you about what's a natural number, what's a whole number. So you need to know what that is. Does anybody know what a natural number is?
I forgot.
Natural numbers.
Oh, I know.
Hold on a minute. What? A whole number greater than 0, right? So in math, the way you would write that is you would say 1, 2, 3, dot, dot, dot.
Oh.
All right? Whole number. Somebody tell me what a whole number is?
Nothing that's a decimal or fraction.
Yes, but more.
Or negative.
Or negative. So what does it start with?
0.
That's right. The only difference between a natural number and a whole number is what? 0. That is correct. All right, now let me ask you this dumb question to see how smart you are.
Wait.
Whole numbers don't go to negatives. All right. So what does dot, dot, dot mean?
And so forth.
Continue on.
And so forth.
Right. So here we go. Listen to me now. If you had to count all the natural numbers and you had to count all the whole numbers, who would have more numbers? Who would have more numbers? What do you think? The whole number? You are awesome.
Yeah.
That's exactly correct. I can still remember arguing with my teacher about that. Right? I said, of course, the whole number. It starts with 0.
But 0 has.
But 0, now watch, listen to the logic. Now I'm trying to teach you something a little bit smarter. All right, not just facts. That was excellent. This right here, listen to me. 1 corresponds with what? 2 matches to what?
1.
3 matches to?
2.
That's why there's the same exact. Does everybody see that?
Oh.
Does everybody see that? It seems to me like it would be infinite plus 1, right? But it's 1 to 1. All right, they have the same amount. All right, it's a very good, very good. That's not really that confusing now. Just think about it. if you just count, if you never stop counting, and one person starts at 1 and the other person starts at 0, it still is going to be the same number. Same. All right, that's very good. Very good. Very good response. All right. So now how do we define integers?
Integers can be like just -1 and then 0 and then 1, 2, and then any negative number that's not a decimal.
All right, so we would write that as,
Like -3.
uh-oh, hold on. You have to do this first, right?
Yeah.
And of course, integers are defined basically as counting numbers and their opposites. Does that make sense? All right. All right. Now, rational. Rational. What does rational number mean?
These can be. Oh shoot! No, I'm forgetting. I'm mixing the rational.
That's all right. No. It's okay. Look, I tried to give you a hint. I gave you a hint.
Fractions.
That's right. Very good. Any number that can be written as a fraction is considered a rational number. That's what rational means. Fraction. Any number that can be written as a fraction. Can 0 be written as a fraction?
No.
Yes, because 0 is the same as 0 over
0.
1.
Oh, I want to.
It could be 0 over 10. Right?
Yeah.
Can we write 5 as a fraction? Of course. Can I write 0.3 as a fraction?
Yes.
Yes. Can I write 0.6 repeating as a fraction?
Yes. No, wait.
No.
It goes every 9,
Yes.
right?
Oh,
Yes,
yeah.
it goes over 9. It goes over 9.
Smart. So it reduces to 2/3, right? So, again, a rational number is any number that can be written as a fraction. If you're describing decimals, what I want you to remember is this. If it terminates, what does terminate mean? If it ends, or if it repeats. For example, 0.371 repeating. Is that a rational number? Yes, it's rational because it repeats. Is everybody happy with that explanation?
Yeah.
So then what do you think, and for your definition, I would like for you to just say any number that can be written as a fraction. Irrational probably means what, Tyler?
A number that never ends in a random order.
Ah, that's very good. Any number that never ends and that's in a random order. Another way of saying that is any number that...
It's non-repeating.
No. Somebody read to me what I said about rational again. What is a rational number? What is it? Very good. Finally, right? So rational means any number that can be written as a fraction. So irrational means cannot be written as a fraction. What's a famous irrational number? Pi. Somebody else? There's another symbol that's irrational. You'll learn in Algebra 2. Good. E. E is irrational. The number or the letter E is considered irrational. All right? The other common irrational, square root of 21. Right? Is the square root of 16 rational or irrational? Rational, because the square root of 16 is 4. Yes, ma'am.
Can rational and irrational numbers be negatives?
Yes. Right? You can have negatives. All right? So, again, if somebody says, what's a rational number? You're going to say any number that can be written as a fraction. If I say irrational, you're going to say any number that cannot be written as a fraction. Is everybody happy with that? All right. So now, what did I spell wrong?
No.
That's, I think, it's the weather outside, right?
Yeah. Oh, that's what EA is the weather outside.
Oh. Yeah, see. You're the first person in probably 3 years that's corrected me.
Wait, but we corrected you earlier with the this one.
Yeah.
Oh.
On my typos. All right, here we go. So, -3. -3. What is that? Rational and integer. That is correct. What is 0? Tell me. Is it a whole number? Yes, and a whole number. Yeah, it is a whole number because remember, whole numbers start with 0. What about 1.6? What's 1.6? Just rational. Very good. 0.17 repeated? Of course, rational also. And then pi is the only what? Irrational number. Yes.
I got here.
Say it again.
Like the symbol for an integer is C, right?
Yeah, very good. Very, very good.
1.6 is just irrational, right?
Just rational.
And so is 0.7.
Any decimal, right? All right. So now, what time do we get out here? I forget.
16. Not 16. It's different. It's 13.
Oh, that's right. It is 13, I think, because they changed it.
Because I have the schedule.
Right? Isn't it 13?
13, yeah.
Yeah, thank you. All right. So now what I want to do is I want everybody to look at number 59, question number 59.
Ooh.
All right. Again, because we're going to practice our mental math with fractions. We're going to practice our mental math with fractions. All right. So the first thing we're going to do is, well, but listen, does everybody remember we would be subtracting 3/4 from both sides of the equation?
Oh, you put on the other side.
Right, we'd be subtracting 3/4, right? So I would want you to be able to, by now, tell me what 5/8 minus 3/4 is. Negative what?
-1.
No.
-2.
Yeah, negative 1/8, right?
Oh, sorry. I just.
Don't be sorry, it's okay. 3/4 is 6/8, right?
Yes.
So now I have, come on, negative 1/2 n is equal to negative 1/8. That's kind of how I would like for you to do it.
Oh, okay. That's okay.
All right, you should be able to do the mental math in here. All right? Now I'm going to multiply both sides by -2, right? Because to undo a fraction, you multiply by the reciprocal. You multiply by the reciprocal.
Yeah.
1/2. The reciprocal of 1/2 is 2/1,
Right.
which is just 2.
But for 1/8, why is it the same?
I don't take the reciprocal of 1/8.
Oh.
You always take the reciprocal of the number that's next to the variable.
Oh, so it's like I guess I think of it as like divide, but since it's.
No, I don't want you doing that. All right, it's easier to think of the reciprocal when you're dealing with fractions. All right, so now I end up with n is equal to, everybody should know, 1/4. Everybody should know 1/4. All right, so now I want to look up here for 57 because I just want to show you what I'm expecting for mental math. Look up now. Here's what you should be able to tell me. 6 equals -6r, r equals -1. All right, look up, please. Look up. It's a review now. All right, this should be pretty easy for you, right? I'm moving the 8 to the other side. Is everybody good with that?
Yes.
All right. Now let's just go ahead and all right, let's practice decimals just so I can show you. All right, I'm definitely going to do what first?
Add ones.
No. Subtract 5, right?
Oh.
I'm isolating the variable, so I'm going to subtract 5. So negative 1.6r is equal to, you should be able to tell me that's negative 12.8. Everybody happy with that? You should also be able to tell me that's the same as negative 16r is equal to negative 128. Do you agree with that?
Yes.
Two negatives make it what?
Positive.
Positive. Is everybody happy with that? Now, here's what I want to impress upon you right here, 128 and 16. Now, a lot of people don't like doing the long division. They don't want to figure out that that's really just 8. So let's say you didn't know that was 8 right off the bat. I'm trying to show you how to divide better now, so look up on the board, please. I know they're both even, right? So I could divide easily by 2. Now look how much easier the problem is.
Whoa.
Oh.
Does that make sense?
That's great.
All right.
I didn't get why the 16 are and the 128 are positive.
Because
Because the
2 negatives, right?
Two negatives.
Negative divided by a negative. I got it. I got it, guys. I got it under control. Is everybody happy with that being 8, right?
Yes.
All right. All right, so let's practice this. Going to distribute the 5, right?
Yes, sir.
So this is going to be 30 minus 20v equals v plus 21, right? I would prefer that the variable would be positive, so I'm going to move the negative 20 over, so that'd make it 21v. Then I'm going to subtract 21, so that'd make it 9. Everybody happy with that explanation so far? All right, just to make sure now, I added 20 to both sides. 1 plus 20 made up 21.
Oh.
Then I moved the 21 to the other side, so to move to the other side, it becomes negative 21.
How much?
So 30 minus 21 is 9. Now be careful, that's just a fraction. So you would say from there, you would say v is equal to 9 over 21, which reduces to 3/7. That's your answer. Now, 65, listen, I want everybody on 65, stop. You honestly should be able to just say the answer is m equals what? There's no work in that. Right? Listen, I'm not trying to hurt anybody's feelings, but if you can't do that, you might be in, right? It might be a little hard for you. Now, I can easily show you, right? But I want your good mental math. That's why we're practicing. So I understand we're just subtracting 2, right? And then dividing by 4. That's a piece of cake. M equals what?
4.
M equals 4. Right? That's what I want you to be able to do. All right? Yeah, let's go back up here to 58. Good idea. All right? So 4n is equal to negative 68, right?
Yeah. Yeah. Because that's a positive.
Oh.
So it makes it not.
So n is equal to negative 17. So everybody happy with that so far?
Yes.
Yes.
All right, now we're going to practice another fraction problem. Your brain should be looking at 3/4 and telling me it's how many twelfths? 9 twelfths. Everybody happy with that?
Yes.
So 11 twelfths minus 9 twelfths is, which is, help me now, if you're not seeing the fraction. Listen, the main thing is, honestly, you got to help yourself. If I'm going too fast, honestly, you just raise your hand and say, slow down just a minute, let me get where you got that number from. Right? But if you never ask me any questions, you're going to bury yourself if you get behind. I'm asking, does anybody have any questions? 5/6 equals 1/6. That's what I'm expecting out of you guys. Now I'm just going to multiply by the, so when you multiply by 6/5, these guys cancel. 6/5 here, C equals 1/5. Everybody happy? All right. Now, here, you should be able to move things quickly in your head. So you should be able to say that's 15x is equal to what? 15x is equal to 12, right? Yes? 15x equals 12. So x equals 12 over 15. And of course, we're reducing that by a factor of. So I'm left with.
4/5.
Nice, right? That's not that bad.
I keep not saying symbols.
What symbol?
Like I do positive ones, negative, and I forget and I flip it and I do subtraction.
Okay.
Okay, so listen, what I'm trying to tell you is I prefer the variable to be positive, so I know this has to come over here. And when I move something, I just change its sign. Right? And then this is a -5, so I add 5.
I see.
You hear me?
I see it missing out.
All right, be careful. Practice another one. All right, on 64, I have to do what first?
The parentheses.
Distribute, right?
Yeah.
So that's going to be,
-6/5 plus -3. I mean negative just.
look carefully, make sure you're there. Now let's combine the terms. So I'm going to move the -6y over, and it's going to become a 12y equals 2. Yes, ma'am.
So whenever you move something over to the other side, the equal sign becomes the opposite.
Do you want me to show you why? Or you good?
Can you show
Why
us?
would be nice.
Okay, so listen. So essentially what we're doing now, I'll show you on this one. All right, so it should make complete sense to you. So you're trying to put the variables together, right? The y's go together. So if I just take this and move it to the other side, right? -6y on the left, right? That's like you just put a -6y on the left. But there was already a what? A -6y over here. So what you do to one side, you have to do to the other. Do you agree? So if I put another -6y over here, yes, this would cancel, but now it's not 0 over here. All right? So let me explain to you what I'm trying to say. All right? If I put a +6y here and a +6y here, do you agree nothing would change? Now let me show you why, because I can kind of tell you that's not making sense. If I said this to you, if I said 15 is equal to 10 plus 5, you would say that's true, right? If I subtracted 10 from both sides, I would get 5 equals 5. It's still a true statement. You with me on this?
Yes.
You understand what I'm saying now, right?
Yeah.
I'm just changing, I'm rebalancing, we could say, the equation, right? So over here, there was a -6y. Since I don't want the y's over on the right side, I want them on the left, I just changed the sign. Why do I do that? Because now what's going to happen with these two, these will do what to each other? Cancel out. And then I would end up with 6y plus 6y, which is what?
12y.
You with me now, right? Now I got to put the other one on the other side, right? So if it's a -5 here, it's going to be a what? The reason why, because now these do what to each other? And now I have 12y equals 2. Does that make better sense now? So once you get to this level, I'm expecting to be able to understand what I'm saying now that you do. So anytime you see a -6y and you put it on the other side, it's going to be what? 6y. If it's a -5 and you want it to go over here, it could be what? +5, right? If I wanted to move the 3 over, it would become a what? If I want to move this over, it would be. Now, I don't like the negatives, right? I'd much rather be what? That's why I move, because it's less chance for mistakes. Agreed?
It's not based on like math, it's just kind of good.
Yes. Right. It's just easier for me to work with positives than negatives. So my answer here is just what? Y equals 1/6, right? Now a lot of people make a mistake and they put 6 there, right? But 12 times 6 isn't 2, right? 1/6 of 12 is 2. Agreed? All right, let's practice 66 and we'll call it a day. All right? So now in this case, am I moving the 5x or the x? The x, because I want to stay positive, right? So if I move x over, it becomes what? Let her think. Let her think.
Oh yeah.
Right, cancel out, right? So if it's positive x on the left, it's going to be negative x on the right. True? So that's going to be 4x. Do you agree? Now the 2 is going to go on the other side. Let her do it. That's correct. Very good. Now don't make the mistake and say x is 2 here, right? X is what? 1/2. Now the reason why is because I'm dividing both sides by 4.
I always just try to find the easiest way.
And 2/4 is what? 1/2.
Oh, 1/2, because you simplify.
So you
Okay, that makes so much more sense.
divide
Got it.
by